For thousands of years, humans have looked up at the night sky, captivated by its beauty and mystery, and wondering what secrets the universe might hold beyond the reach of our eyes. From ancient astronomers charting the stars to modern-day dreamers, our curiosity has always driven us to explore the cosmos. Now, with the launch of the James Webb Space Telescope, we have a revolutionary new tool. One that offers our clearest, most detailed view of the universe yet, opening a new chapter in space exploration. Floating a million miles from Earth, Webb is both a time machine and a super-powered camera. It peers deeper into space and further back in time than any telescope before it, capturing the faintest light from the earliest galaxies. Its secret weapon? Webb sees the universe in infrared light, which is essentially heat energy. This allows it to look straight through thick clouds of cosmic dust that block visible light, revealing stars and planets that were once completely hidden from view. Thanks to this incredible power, Webb has sent back breathtaking images, dazzling galaxies, swirling nebulae, and mysterious objects that have already transformed our understanding of how the universe works and how it has evolved. Among its most thrilling missions is the search for exoplanets, distant worlds orbiting stars far beyond our solar system. Webb is helping us find planets that could be similar to Earth, and maybe even capable of supporting life. Each new planet Webb uncovers is like a piece of a vast cosmic puzzle, helping scientists piece together the story of our galaxy and the potential for life elsewhere in the universe. Its latest discovery has the scientific community buzzing with excitement, sparking new questions and inspiring fresh theories about the nature of planets, stars, and the origins of life itself. The James Webb Space Telescope is the result of decades of work by thousands of people from all over the world. It stands as a symbol of what humanity can achieve when we work together, driven by curiosity and the desire to understand our place in the cosmos. Today, we celebrate one of Webb's most exciting discoveries, a breakthrough that brings us closer to understanding how planetary systems like our own form and evolve, and what makes a planet truly special. This is the spirit of exploration, to push the boundaries of what we know, to venture into the unknown, and to keep searching for answers to the biggest questions. As we look up at the stars, we're reminded that the universe is vast, mysterious, and full of possibilities. And so, we keep asking, what else is out there, waiting to be discovered? Meet TWA 7, also known as CE Antilli, a young red dwarf star just 111 light-years away, practically our cosmic neighbor. This star sits in the constellation Antlia, and while it's invisible to the naked eye, it's a fascinating object for astronomers. TWA 7 is part of a group of young stars called the TW Hydrae Association, a stellar nursery where new worlds are just beginning to take shape. Its proximity to Earth makes it a perfect laboratory for studying the earliest stages of planetary systems. At only 6.4 million years old, TWA 7 is a baby compared to our 4.6 billion-year-old sun. Imagine the difference. While our sun has seen the rise and fall of planets and life, TWA 7 is just getting started, still surrounded by the leftovers of its own birth. This youth means its environment is dynamic and full of potential, with processes unfolding that shaped our own solar system long ago. Surrounding it is a vast, multi-ringed disk of dust and debris, the raw material for planet formation. These swirling rings are made of ice, rock, and cosmic dust, all colliding and clumping together. Over millions of years, these ingredients can come together to form planets, moons, and asteroids, just as they did in our own solar system's past. These rings have mysterious gaps, long suspected to be carved by hidden planets. As young planets orbit, they clear paths in the dust, leaving behind telltale signs of their presence. These gaps are like cosmic fingerprints, hinting at the invisible architects shaping the system. TWA 7's disk is perfectly angled for us to observe, making it an ideal target for Webb's powerful gaze. From our vantage point, we can peer directly into the heart of the system, watching the drama of planet formation unfold in real time. Red dwarfs like TWA 7 are the most common stars in our galaxy, so finding planets here could mean they're everywhere. If planets can form around these small, cool stars, it suggests that the ingredients for life might be scattered throughout the Milky Way, orbiting countless red dwarfs. The gaps in the disk are clues, and scientists have been eager to catch the planet responsible. By studying these features, astronomers hope to learn not just about TWA 7 but about how planets form and evolve everywhere. Webb was pointed at TWA 7, ready to solve the mystery of the missing dust. With its advanced instruments, Webb can peer through the dust and reveal what's hiding within the rings, offering a glimpse into the earliest moments of planetary birth. The hunt for a hidden world was on. With every observation, astronomers moved closer to uncovering the secrets of TWA-7, and perhaps the origins of planets like our own. Spotting a planet next to a bright star is like finding a firefly beside a searchlight. The star's brilliance overwhelms everything nearby, making it nearly impossible to see anything faint and delicate in its glow. For decades, astronomers have struggled with this challenge, searching for ways to peer past the blinding light and glimpse the hidden worlds that might be orbiting close by. It's a cosmic game of hide-and-seek, where the prize is a new planet waiting to be discovered. Dr. Anne-Marie Lagrange's team used Webb's MIRI instrument and a coronagraph, a high-tech sunshade, to block TWA-7's glare. The James Webb Space Telescope, with its advanced technology, was designed for just this kind of challenge. The coronagraph acts like a shield, carefully masking the star's intense light so that astronomers can search for the faintest signals nearby. With the star's light dimmed, they searched for faint, warm objects in the disk's gaps. These gaps are like clues, hints that something massive, perhaps a planet, might be shaping the dust and debris around the star. The team pored over the data, looking for any sign that a hidden world might be lurking in the shadows. After careful image processing, a tiny dot appeared, right where theory predicted a planet should be. It was a subtle signal, almost lost in the noise, but it stood out just enough to catch the astronomers' attention. This was the moment they had been hoping for. This wasn't just a random speck. Its brightness, color, and location matched the profile of a young planet. The data suggested it was warm, glowing with the heat of its formation, and sitting exactly where a planet would be expected to shape the disk. They named it TWA-7b, following the tradition of adding a letter for each new planet. This simple label marked the beginning of a new story in the study of distant worlds. This was a breakthrough, direct evidence of a planet shaping its system. For the first time, astronomers could see the impact of a young planet on its surroundings, confirming years of predictions and models. Years of theory and technology had paid off. The journey from idea to discovery was long, filled with setbacks and innovation, but perseverance had finally revealed the truth. Webb's power had revealed a world that until now existed only in calculations. The telescope's sharp eyes turned a mathematical possibility into a real, observable planet. The firefly was finally found. Against all odds, a tiny world emerged from the darkness, shining with its own light. A new chapter in exoplanet discovery had begun, opening the door to countless hidden worlds waiting to be found. With TWA-7b discovered, scientists raced to learn more. Webb's data showed it's about 0.3 times Jupiter's mass, roughly 100 Earths, making it the lightest exoplanet ever directly imaged. Its temperature? Around 47 degrees Celsius, 117 degrees Fahrenheit, still warm from its recent formation. TWA-7b orbits 50 times farther from its star than Earth does from the Sun, deep in the system's outskirts. This wide orbit helped Webb spot it, separating its faint glow from the star's brilliance. TWA-7b is a massive, young, warm planet on a distant path. Its details, mass, temperature, position, help us piece together how planets form and evolve. It's a world unlike any in our solar system, but it's teaching us about our own origins. Each discovery like this brings us closer to understanding the galaxy's diversity. TWA-7b is a new character in our cosmic story. How does TWA-7b compare to planets we know? With a mass similar to Saturn, it's a gas giant, not a rocky world like Earth. But unlike Saturn, which is icy cold, TWA-7b is still warm from its youth. Over time it will cool and may one day resemble the icy giants in our solar system. Its distant orbit is more like Neptune's, but it's much more massive, a super-sized cousin living in the system's far reaches. These comparisons reveal the universe's creativity in building planetary systems. TWA-7b challenges our assumptions, showing that planets can be massive, warm, and distant all at once. Each new world expands our imagination and understanding. The diversity of planets is greater than we ever imagined. TWA-7b is proof that the universe is full of surprises. The real excitement isn't just TWA-7b's existence, it's what the planet is doing. Found inside a gap in TWA-7's disk, TWA7b is direct evidence that planets carve out these gaps, shaping their systems. For the first time, we're watching a planet in the act of cosmic construction. The planet's mass and position match predictions perfectly, confirming years of theory. TWA7b may also explain hints of a Trojan disk, dust trapped in the planet's orbit, like cosmic companions. Future Webb observations will search for this, revealing even more about planet-disk interactions. TWA7b isn't just a planet, it's an architect, sculpting its solar system. This discovery is a leap forward in understanding how worlds are built. By studying TWA7b, we glimpse our own solar system's ancient past. We're witnessing the laws of physics at work, building a new world from scratch. Every new planet raises the question, could it support life? TWA7b's temperature, about 47 degrees Celsius, falls within the range where liquid water could exist. This puts it near the habitable zone for its star, sparking excitement about its potential. If such planets are common around red dwarfs, the universe may be teeming with life-friendly worlds. But TWA7b is a gas giant, with no solid surface for life as we know it. Still, large moons orbiting such planets could be habitable, warmed by their giant parent. TWA7b itself is unlikely to host life, but its discovery is a crucial step in the search. It proves we can find planets with Earth-like temperatures. Next, scientists will use Webb to study its atmosphere, searching for water and other signs of habitability. TWA7b is a tantalizing clue in our quest for life beyond Earth. TWA7b's discovery is a scientific milestone, the lightest exoplanet ever directly imaged by Webb. It proves we can now photograph planets similar in mass to those in our own solar system. This achievement is the result of global collaboration and years of effort. For scientists and dreamers alike, it's a moment of wonder. We're no longer limited to shadows, we can see new worlds directly. Knowing there's a Saturn-sized warm planet shaping its system 111 light-years away is awe-inspiring. Discoveries like this spark curiosity and inspire us all to keep exploring. The discovery of TWA7b is just the beginning. Webb's success opens a new era of exoplanet exploration, with scientists eager to find more worlds like it. Follow-up observations will refine what we know about TWA7b and search for signs of water and other molecules. Hundreds of young stars with dusty disks are now prime targets for Webb. Each new planet adds to our understanding of the universe's diversity. We're closer than ever to answering the age-old question, are we alone? TWA7b proves our technology can find worlds with the right conditions for life. The universe is full of wonders, and our journey has only just begun. Keep looking up, the adventure is just beginning.